Okay, so again we are back. Listen one thing, that every time I am telling this, the way things are being made, right, only your job will be to solve more numericals from the book, right, although many things have been done, right, but as far as theory is concerned, more or less everything is covered, right. So next we will consider that series RLC circuit. First we saw that your purely resistive circuit, then we saw purely inductive circuit, then we saw purely capacitive circuit. Step by step we are moving. Now we will consider series your RL circuit, right. So here you have to make instantaneous polarity, plus minus, right, and current flowing through this is it is a simple series circuit, right, and voltage across the resistance is VR and across the inductance is VL, right. Our objective is a steady state analysis, right. So current, the V is given. Now we will assume let I is equal to Im sin omega t, right, that we will assume. So just either a voltage or current, something you have to assume, right. So if you assume I is equal to Im sin omega t, before moving is that whenever you make I is equal to Im sin omega t, that means in general your what you call, it will be RMS value will be Im by root 2, I mean if you write like this, and reference will be angle 0, because it is omega t. So omega t plus 0 degree, right. So that means it is Im by root 2 0 degree. So this is the RMS value, right. Anyway, so next is instantaneous voltage, that is VR plus VL is equal to V. So V is equal to this, VR is equal to current flowing through this is your what you call this I is the current, right. So it is IR, and then it is L into your di by dt, that is your VL. VL is equal to V, right. So V is equal to VR, that is IR plus L into di by dt. Now I is equal to Im sin omega t, right. Therefore your, if you substitute here, it will be R Im sin omega t plus omega L Im cos omega t is equal to V, right. Then what you do, you take Im common, right. So Im is here, then this is your R and this is your omega L. So this is your R Im, this is say omega L Im. So this is root over R square plus omega L square Im. In general, if you take here Im common, so in general here it is coefficient, then is R, right, it is R square you take, and here it is omega L square. So numerator and denominator both side you divide by root over R square plus omega L square, R square plus omega L square is equal to V. So V by root over R square plus omega L square, both side of this equation you divide by root over R square plus omega L square, and this Im you take common, and here from this angle is theta. So cos theta is equal to R upon root over R square plus omega L square, and sin theta is equal to omega L by root over R square plus omega L square, right. Therefore now question is that this is your cos theta, this is your sin theta. So this one you replace by cos theta, and this one you replace by sin theta. Then your Im it is common into sin omega t cos theta plus cos omega t sin theta, that is sin A cos B plus cos A sin B form. So let me delete it. So that means from which you will get that your V is equal to Im root over R square plus omega L square sin omega t plus theta, and this is given, your sin theta cos theta is given, cos theta is equal to R upon root over R square plus omega L square, and sin theta is equal to omega L by root over R square plus omega L square. So this one we can write, this one is equal to your what you call V is equal to Im into Z into sin omega t plus theta, that is equal to Vm sin omega t plus theta. That means this Im into this one root over R square plus omega L square, this is the term. So Z is equal to root over R square plus omega L square. This is actually your impedance of this RL circuit, right. So and your Im into Z and Vm is equal to your magnitude, these are all magnitude, Vm is equal to I into Z, this is also magnitude, right. Therefore Z is equal to root over R square plus omega L square is equal to Vm by Im. So this Z is equal to, I am writing for you, Z is equal to, right, when we write Vm by Im, right, basically it is equal to Vm, I hope you can see it, Vm by root 2 divided by Im by root 2, right. So that means RMS value. That means your, let me clear it, that means Z is equal to the impedance magnitude is equal to Vm by Im is equal to V by I, where V is the RMS value of the voltage and I is the RMS value of the current. When you solve the numericals, we will use Vrms upon Irms, understandable, right? So, and that is why it is writing Vm upon Im, you can write V upon say I, if we say V is the RMS value and I is the RMS value, because both numerator and denominator you are dividing it by root 2, and theta is equal to tan inverse omega L by R, right. So, this is your just let me clear it, this is your, if you look into this diagram, right, here tan theta is equal to your L omega by R, because Im will be cancelled. So, L omega by R, that means theta is equal to tan inverse omega L by R, right. So, let me clear it. Therefore, here it is given that your theta is equal to tan inverse omega L by R. So, this is your tan inverse omega L by R. In this case, what is happening, that two things, that this is we choose, actually we took I is equal to Im sin omega t, right, that we took. So, if you take in terms of your what you call in the phasor, that when we draw the phasor diagram, so generally we can write I is equal to Im by root 2, that RMS value, and its angle will be 0 degree. So, this is your RMS value. So, if we define this, that it is capital I, then it will be I angle 0, I is the RMS value, right. So, that is why this I is taken as a reference, this is capital I, this is capital I. So, this is your I, the reference, right. Now, next is, let me clear it, next is my V. So, V is equal to, actually it is Vm sin omega t. So, V actually is equal to Vm sin omega t plus theta, omega t plus theta, this one theta. So, this can be written as in the terms of your, when you draw the phasor diagram, Vm angle, so when you take the RMS value Vm by root 2, and this one can be taken as theta, angle theta. So, this can be written as V angle theta. V is the RMS value, V is equal to Vm by root 2. Similarly, I is equal to Im by root 2, the RMS value, right. So, V is the RMS value. So, here an angle is theta and theta is positive. So, this V is there. So, this is my V and this angle is theta. That means, current I is lagging from this voltage V by an angle theta, or V is leading the current I by an angle theta, right. And another thing is, let me clear it, just hold on, let us go to the diagram. Another thing is that this diagram. So, here VR is equal to your IR, right. This is your what you call that voltage drop across the resistance. So, we can make this IR if it is RMS value, and of course, instantaneous polarity is there. And VL, this is the inductive reactance, and inductive reactance means XL is equal to your JL omega, right, JL omega. That means, your voltage drop VL is equal to JIL omega, that is IXL. So, it is VL is equal to J into IL omega, right. Therefore, because for your what you call, for purely inductive circuit, we have seen it is JL omega, right, that your what you call that your current lags 90 degree from the voltage, right, for purely inductive circuit, and it was basically on the imaginary axis, right. So, JL omega. So, this is your R and this is JL omega. So, let me clear it. Therefore, this one is your VR is equal to IR, and this one is VL is equal to, this is your VL is equal to JIL. J means angle 90 degree, right. If you take like this, JIXL is equal to IXL, and J means angle 90 degree, because angle 90 degree means cos 90 degree plus J sin 90 degree. So, cos 90 0 and J sin 91. So, then sin 91. So, it will become JIXL. So, this is JIXL and this is the resultant V, right. Now, let us come back your what you call to the diagram once again. That means that impedance of an inductive circuit, Z is equal to, we can write R plus JL omega, right, because this is purely resistive R and this is your inductive your what you call L. So, its reactance is your L omega. So, R plus JL omega. That means, if you take like this, suppose this is a complex quantity put bar is equal to, that is magnitude is R square plus L square omega square, this is its magnitude, and its angle will be your tan inverse L omega by R, right. This is your Z bar is equal to your, and this is the magnitude. That means this one, that means Z your what you call your Z bar is equal to Z angle theta. So, theta we have defined, that is tan inverse L omega by R, and Z is the magnitude of the impedance. So, any your what you call when inductive circuit it is, so R plus JL omega, right. So, this is the impedance of the your what you call the circuit. When you solve the problem, you will know how things are, right. So, let me clear it. That means, in general when you compute the current, suppose this V is given, we got V is equal to Vm sin omega t plus theta, that we got. So, that means, if we put in RMS value, it will be V is equal to Vm by root 2, right, and angle your theta, right. So, and if you try to find out what is the current, so current should be equal to, here you can make it, if you want it is your phasor, so make it V arrow, I is equal to then this one V arrow by divided by that your impedance Z. So, that is equal to, it is V angle your what you call theta, sorry this one your V is given here your what you call angle theta, and divided by, if you made this I, this Z, it will be R plus JL omega, right. So, in that case, look how things will come. In that case, your this is my I, this is my I, this is also phasor quantity. So, this is my I. So, this is your V angle theta divided by this R, means it is Z angle theta, Z is equal to root over R square plus L omega square. So, that means is equal to V by Z angle theta minus theta is equal to V by Z angle 0 degree, right. That means, the current whatever we have got, we assume no I is equal to Im sin omega t, that is nothing but your I angle 0 degree. So, this is also V by Z is I angle 0 degree, because I just show you the reverse calculation when you will solve the circuit problem, at that time you will see into this, I just came from the back, right. So, this is I angle, and it is coming no J your what you call, this one is equal to I angle 0 degree. If I make it your in terms of phasor, because I is equal to Im by root 2 RMS value and angle 0 degree whatever it is coming here, right. So, let me clear it, little bit understanding is required, right. So, once it is done, so this is what you call that your Z is equal to, I told you that R plus J omega, and this is your magnitude, we call XL is equal to L omega, and this is tan inverse XL upon R or L omega by R, I told you. Now, the instantaneous your what we call value of the power is given by power is equal to V into I. So, V you substitute Vm sin omega t plus theta into Im sin omega t, right. So, this one you just expand it in sin A cos B and plus your what you call cos A sin B, and you multiply. If you do so, it will come Vm Im upon 2 cos theta minus Vm Im upon 2 cos 2 omega t into cos theta plus Vm Im upon 2 sin 2 omega t sin theta. Now, the average value of the power, it is 1 upon t 0 to t Vm sin omega t plus theta into Im sin omega t dt, that means this expression, right, this expression. So, directly we are putting it, and if you put it and try to integrate it, you will use this relationship omega is equal to 2 pi by t, that means my omega t will be is equal to 2 pi, right. If you do so, the integrate it will become Vm Im upon 2 cos theta. So, cos theta is the power factor, right, that means it is the angle between the voltage and the current, that means this one, this is your this theta, this is the angle between the voltage and the current, right. So, this is actually it is coming Vm Im by 2 cos theta. That means this Vm Im by 2 means you can write this one Vm by root 2 into Im by root 2 into cos theta, right. That means this is my RMS value, this voltage, and this is RMS current. That means it is Vi cos theta, whereas V is the RMS value of the voltage and I is the RMS value of the current multiplied by the cos theta, and cos theta is the your power factor of the circuit. Theta actually angle between the voltage and current, right. So this is actually Vi cos theta. So that means this one we can write Vi cos theta, right, and V and I both are the RMS quantity, right. Otherwise, if you take the peak value, it will be Vm Im cos theta upon 2, but generally we will use always RMS value in our numericals, right. So let me clear it. Next is that your what you call that another way of doing this, and this is your what you call, I am telling this is your power, right. This is the plot of the power, this is the current, this is current is marked, this is current, right, and this is your this dash line is the voltage, and this is the Vi and power, Vi and P, all these things are shown, right, just for the purpose of your that giving you some feeling that they are waveform, right. So this is the power. If you plot P is equal to V into I of this one, I mean this one, if you plot, the plotting will be like this. Now another way of expression of this one is that this is 1 upon t 0 to t, this is easier one, Vm Im sin omega t plus theta into sin omega t. So what you can do is that numerator and denominator you multiply by 2, that means here you multiplied by 2, right, divided by 2, you numerate, then it is 2 sin A sin B. You expand this one, 2 sin A sin B is equal to your what you call cos A minus B minus cos A plus B, right, and if you do so and expand it, it will simplify, it will become like this. So it is numerator and denominator you multiply by 2, and then you just 2 sin A sin B formula use from your class 11 trigonometry, right. So your what you call, it will be 2 sin A sin B is equal to cos A minus B minus cos A plus B. So if you do so, you will get this one. Therefore it will become Vm Im upon t 0 to t cos theta dt, right. So if you integrate from this one because this term actually will vanish, and finally it is again becoming your half Vm Im cos theta is equal to Vm by root 2, I told you Im by root 2 into cos theta is equal to Vi cos theta. V is the RMS value and I is the RMS value. Other terms contain 2 omega t, the average value of which over a complete cycle is 0, right. If you do integration, you will see this will become 0, right. So this is the idea. Next we will consider that your series RC circuit, right. It is same like your inductive circuit, but here it is C. So in this case again we assume I is equal to Im sin omega t, right, and it is instantaneous polarity, and this current I means it is flowing like this, it is series circuit, RC circuit. So V are same as before, this voltage across resistance, let me clear it, voltage across this one is VR and voltage across this one is Vc, right, and this is your instantaneous polarity. So in this case Ri, and you know that I is equal to C into dV by dt, from that you can write Vc is equal to Ri 1 upon C integration I dt is equal to V, right. Then you write Ri, your I is equal to then your Im sin omega t, and this Im sin omega t you put it here, I is equal to I and integrate, it will become minus 1 upon omega c Im cos omega t is equal to V, right. So same as before. So this is Im you take common, and here it is given omega c Im multiplied, here also Im multiplied. So voltage drop is multiplied, this is Rim, and this angle is theta, right. So in this case this is your what you call this sin omega t, both side what you can do is you divide by r square root over r square plus 1 upon omega c square. If I divide both side, then right hand side will be V upon root over r square plus 1 upon omega c square, right, and that means this one, this is your sin omega, this is your sin omega t, and if you look into this diagram, right. So cos theta will be this is my base, Im will be cancelled, right, by root over r square plus 1 upon omega c square, this is cos theta, and then sin theta will be is equal to your 1 upon omega c by root over r square plus 1 upon omega c square, right. So this one, that means this one can be replaced, this one can be replaced by your cos theta, and this one can be replaced by sin theta, right. So, accordingly this here it is cos theta, and here this one is your sin theta, and this is equal to your what you call multiplied by your this one, your Im into root over r square plus 1 over omega c square is equal to, again because this one is cross multiplication, right. So, if you do so, same as like inductive circuit, here it is 1 upon omega c and 1 minus sign is there. So, in this case also it is becoming V is equal to Imz, V is equal to Imz sin omega t minus theta, right. So, is equal to Vm is equal to your Vm sin omega t minus theta, and Vm is equal to Imz. So, Vm is equal to actually is magnitude Imz, right. So, sin omega t minus theta. Thus, we get Z is equal to root over r square plus 1 upon omega c square, and again is equal to Vm by Im is equal to V by I, where V and I is the RMS value. Earlier I told you this one also is equal to V upon I, V is the RMS value and I is the RMS value. Wherever we will find solve the numerical, we will use most of the cases only RMS value, right. And theta is equal to tan inverse your 1 upon omega c by r, but one your what you call that one minus sign is there, right. So, in the case of your what you call two things you can do is that it is tan inverse, and if you your this thing your minus 1 upon omega c r, right. In the case of inductive circuit, it was your what you call theta was positive, it is tan inverse L omega by r. In the case of your what you call in the case of capacity RC circuit, it will be theta is equal to your what you call tan inverse minus 1 upon omega c. So, theta will be negative, right. So, in this case what is happening that just let me move little bit up. In this case what is happening that your voltage actually lagging from the current by an angle theta, or this current I actually leading this voltage by an angle your what you call theta, because this angle is theta, this angle is theta, right. So, Vc is equal to same as before j into your minus j into Ixc, that is Xc is equal to 1 upon omega c. So, that is minus your I into 1 upon omega c, right, and this is my voltage V. Therefore, V is equal to V plus Vc, that means my IR minus j your V, actually this is my VR, and then your what you call plus Vc, Vc actually is equal to minus I into j into 1 upon omega c, because this is your minus ji 1 upon omega c. So, that is equal to R minus j omega c. That means impedance for the RC circuit, it is R minus j upon omega c, right. So, that means this is equal to your what you call is equal to I into z. Therefore, impedance of the circuit is this one, and impedance, that means this is the magnitude, and this is tan inverse minus 1 upon omega c. So, this minus sign is taken out, here it is minus tan inverse 1 upon omega c by r, but minus is here. So, minus theta we are writing that way, right, or we are writing root over r square plus x square minus tan inverse xc by r, where xc is equal to 1 upon omega c, right. That means, for that your series RC circuit, Z is equal to this one R minus j 1 upon omega c, right. So, generally what happens that xc, when we write like this, sometimes we write R plus your what you call jxc. In that case, your xc actually your what you call, if you write R plus jxc, then in that case what will happen that you this xc value you have to take negative, that way you do not do. What we do, let me delete it. What we do, if you write R minus jxc, then you will take xc is equal to 1 upon omega c, right. So, this is actually your capacitive your reactance 1 upon omega c, right. So, it is R minus j. So, for the inductive case it is R plus jxl, and for capacitive case it is R minus jxc, and xc is equal to 1 upon omega c, right. So, that means now same as before, the instantaneous value of the power. So, it is your V into I, and you multiply this together, you multiply, and then it will be average value of the power 1 upon t 0 to t, same thing. So, here also numerator and denominator you multiply by 2, and it is 2 sin A sin B, that is cos A minus B minus cos A plus B. Put that, use that formula, and you will get again it is half V A by m to cos theta is equal to V I cos theta. V is the RMS value of the voltage and I is the RMS value of the current. So, once again I am writing for you, V is equal to V m by root 2 and I is equal to I m by root 2, the RMS value of the current, right. And the diagram is shown here for the power, voltage and current, right, just to give you a feeling that how actually this this one you plot, this is the dash line, the dash portion shown, it is the power part, right. So, just to give you a feeling that how it is. So, this is actually now we see our series RLC circuit, series RC circuit. Now, we will see series RLC circuit, right. So, now for series RLC circuit we have three elements are in your what you call are in series. So, it is voltage across R is VR, voltage across L is VL and voltage across this C, and you put instantaneous polarity plus minus, current flowing through this is I. Now, one thing I will tell you that voltage and current this is it is a I told you in AC circuit phasor is a rotating vector. So, angle of the voltage, this is first quadrant, this is second quadrant, this is third quadrant, this is fourth quadrant, right. So, voltage or current, right, the angle of the voltage and current, it can be in anywhere because phasor is a rotating vector. It may be in according to your circuit diagram, network, angle, everything, right, impedance, what type of thing you have taken. According to that voltage or current phasor, it may be in first quadrant, it may be first or second or third or fourth. So, it may be in either of all the your what you call all the four quadrants, it may be anywhere, right, because it is a rotating vector. So, that angle of the voltage and current, but if you look at the impedance when you write one or two places, let me rectify you, one or two places when I am making the notes, some places it is written Z arrow. So, your impedance is not a your what you call is not a phasor quantity, because Z is equal to in general R plus Jx you put, right. Now, if you take this quadrant, R is always positive. So, R should be somewhere here on this axis. Now, depending on the circuit is inductive type or capacitive type, this either it will be somewhere here x by, if it is inductive type then it will be somewhere here, right, Z will be somewhere here. If it is capacitive type, so it will be the your x will be negative, so maybe it will be somewhere here, so this side. So, either in the first quadrant or in the fourth quadrant, but here it should not be there because R is always positive. So, hence my conclusion is that this thing that Z actually is not a it is a complex quantity, but it is not a phasor quantity, right. Phasor is a rotating vector, so angle can be anywhere. For Z, angle may be either first or in the fourth quadrant, right. So, next is that series RLC circuit. So, V is equal to VR plus VL plus VC, because all these things are given. So, VR is equal to IR and VL is equal to we saw JILXL as JIXL, and your VC is equal to minus JIX. Everywhere it is shown this arrow phasor, but even it is not there also, it is understandable that it is a phasor quantity, AC quantity, right. So, if you take I common, so everywhere I will not take I arrow. So, this is nothing, this is your Z bar, right, this is a simple complex number. So, I R plus JXL minus XC, therefore, Z is equal to R plus JXL minus XC, that means it is R, XL is equal to L omega and XC is equal to 1 upon omega C. Therefore, its magnitude will be root over, it is a complex quantity, magnitude will be root over R square plus omega L minus omega C square, and angle will be tan inverse L omega minus omega C upon R, that is omega L minus 1 upon omega C by R, this will be the angle, right. Now, if it is given that if VL greater than VC, that is VL greater than VC or if XL greater than XC, right, that means circuit will behave like inductive circuit. If XL greater than XC means that is your omega L minus omega C greater than 0, that means it is positive, that means my angle theta will be positive. That is why here it is VR is equal to RI and this one is your what you call, this side is VL, this side my VL JXL IL, this is just for the sake of completeness, this is minus JXCI, this side is negative side, that is why minus, but when you will take the your what you call, you will take the difference VL minus VC, it will be actually XL minus XC into I, right. So, if you do so, if you multiply this R plus I into J XL minus XC, so this is actually this, but at the same time it is VC is given minus J, here it is VL, but do not take VL minus VC means it will become plus, do not do that. It is VL your what you call minus VC is taken. So, here this side is negative side, that is why you have taken, but when you take this difference, please do not do that. At that time you make J into XL minus XC. This is the phasor representation. So, this side no need to put your, even if you do not put your what you call the negative sign, it does not matter, because this is negative side, but just to for the sake of your completeness I have made this one, right. So, this is your anyway, this is your instantaneous polarity, and that resultant will be, that is VL greater than VC. If XL minus XC greater than 0, then naturally VL will be greater than VC. So, that means circuit behavior is like inductive type circuit, because theta is positive, because theta is equal to omega L minus 1 upon omega C by R. So, omega L minus 1 upon is greater than 0 is positive. So, that means my theta will be positive, because theta, this angle is actually theta. So, theta will be positive. So, phasor diagram will be like this, right. So, this is your resultant, this side, because VL greater, because XL greater than XC means VL greater than VC. So, this is the resultant portion VL minus VC, right, and this is theta. So, that means this circuit behave like inductive type. Similarly, that if it is your VL less than VC, right, that means your XL less than XC. Suppose if your VL less than VC, that means my XL less than XC, just opposite. So, in that case, not giving it same thing I explaining, in that case theta will be negative. So, this is my I, this is angle theta. So, this will be now VC minus VL. So, do not confuse with this sign, this is to show this one, right, but when we take the difference of this, do not ignore this one, it will be just J, your VC minus VL will be what you call J, your what you call, it will be J XL minus XC into I, right. So, if you do not put here, it does not matter. So, in this case it will be VC minus VL, because VC greater than your VL. So, coming to this side, so that means this is my theta. So, that means theta is negative. That means my your what you call that circuit behavior is like a capacitive circuit, because in this case XL less than XC means your L omega minus omega C, this is your less than 0. So, it is your what you call that your 1, that means my 1 upon omega C greater than L omega, that means my XC greater than XL, right. So, here it is written XL your XC greater than XL or XL less than XC. So, that is why circuit behavior is here like your this thing, and this one should be your bar, right. It is not a phasor, it is a few places it is written there. So, Z is not a phasor quantity, right, it is a complex quantity. So, anyway, so this is your when your VL less than VC, so circuit will behave like your capacitive your what you call that your capacitive circuit, right. So, with this, right, so with this your just your take this example that Vt is equal to is given 100 sin 40 t, that means 100 sin omega t, that means omega is equal to 40 radian per second, right, and R is equal to 10 ohm and L is equal to 0.2 Henry and capacitor is given C 0.0014 farad, right. So, you have to find out IT, VRT, VLT and VCT, right, all these things you have to find out. Then you have to find out, calculate the power loss, and you have to show the phasor diagram, right. So, this is the circuit, you have to take a instantaneous polarity plus minus, this is given, and this is your Vt already given 140 100 sin 40 t, and this is your VR voltage across R, this is L, that is voltage across L, and this is C, voltage across capacitor C, right. So, you have to find out your what you call that your IT, VRT, VLT, VCT, all these quantities. Thank you very much, we will be back again.